Hello grade 12s, welcome to my channel and hopefully you guys are doing great. So let's have a look at some more trigonometry where we get to apply our trigonometric identities that we derived ourselves and hopefully understand them now enough to use them, freely. Now, we took it to all of the identities you will ever have to know for grade 12. Now it's time to put them to use, okay? So let's just look at this question 3. Okay. So in trigonometry, guys, I use what I call the doctor's approach. The doctor's approach. Of course, guys, I'm being silly here. Don't take it too seriously. Okay, so the doctor's approach. What does a doctor do when you get to their consultation room? Well, they apply the so-called SOAP system because there's no time, guys, for crazy things. The SOAP system, the S is standing for subjective information. Of course, here they use history, okay? We call it taking the history. So it's all about subjective information, how the patient feels, and exactly what led them to consulting the doctor. And now this is the piece of information given in a question, because that which is given is what is going to be used to sort of answer the questions. Now, after that, we objectively, so this is objective info. Now, some people would call this an examination or a clinical examination. So you just examine objectively that piece of information. What does it imply? Or what does it give you as the one listening to this story? Combining with your examination, are you coming to some sort of an assessment? Right? So that would be the assessment, meaning after that you understand where you are. Okay, this is this is that, this is that. Now, with all of that, what's the plan? Because now this is actually us answering the question. Of course, when it comes to the plan, doctors do other things. They'll order some investigation, some imaging, they can take a biopsy if there's a mass lesion. There's a lot of things they can do, or they can take it straight to theater. Now, we are going to dissect this using the 3-step approach. Oops, approach in an approach. Yes. If you don't know what the 3-step approach, well, you are going to find yourself dead. Let me just map it for you guys, because I know you're not paying attention sometimes. We use BODMAS or BOMDAS, PEMDAS, you name it. So this gives us 80% of our solutions, because this is us treating our patient, essentially. But sometimes we may get stuck, find that, hey, there's a huge mess here that is causing this patient to keep losing consciousness, and this can kill the patient. How about we go and debulk that tumor first before we can irradiate it? Well, this is factorization. Okay, so when we factorize, we know 3 formats. Highest common factor. We actually do the difference of 2 squares, called it dots. And the third one is any trinomial, let's just say polynomial, because that would be long division essentially. That's it. Trinomials and more, we use long division, but for a trinomial it's much easier. We say bracket method by inspection, but technically it's all built from long division. All right, so that would be the 2nd step. Now the 3rd step of our 3-step approach. Now this is the treatment of our patient. If we can't give medication, we do surgery. If we can't do surgery, we give radiation, isn't it? Okay. And of course more, we can order physiotherapy. So this is perhaps identities now, because we are dealing with trigonometry. So I will try not to go to other issues, but identities so far is key. But as I mapped out earlier in my earlier videos, that the third part may include laws of exponents. It can be an it can be a formula. It can be just pure logic times, anything can fit in there. All right, anything can fit in there. So let's just try to treat our problem using this very approach, because the plan is when we're actually answering the questions from understanding what we are dealing with. So let's read. What are we given? We are given point P with coordinates A and -40 with OP, that is 41 units. So that's the length from the origin to point P. So this is on the Cartesian plane. And POX, this is now the angle, which is theta, where theta is greater than or equal to 270 degrees, or is less than or equal to 360 degrees. So just there, where are we? We are on a Cartesian plane, right? And this Cartesian plane is already telling us that our angle theta is an angle in the fourth quadrant. Okay? And our terminal arm is essentially there. Okay? That's what this is. And this is point P, which has coordinates A and -40. And we are told that OP is 41 units. So we ground this onto the x-axis. All right. And we know that this is such that it would be perpendicular. But anything that was not given, we break it up because it's a mere construction. And we were told that our theta is going to be this angle. It's a reflex angle in the fourth quadrant. See, we were given information that we understood well. From understanding that piece of information, we then examined it. We got the impression that indeed this thing is a reflex angle in the fourth quadrant. And we placed all those values. And we know essentially that this length is therefore going to be 40 units. Spare that it is negative. Okay, maybe let's put the sign together. But this is a length, so a length is never negative, but we will take this as a coordinate. So this is -40, that is 41, and that is A. Okay, so once everything is where it is, we realize that, we are missing A here. So we don't need a second invitation for this. We know that x squared plus y squared should give us r squared. This is from Pythagoras. We go on, and substitute x with A, y with -40, and r with 41 squared. All right, so here we can show that A squared is going to be 41 squared minus 40 squared. Therefore, A here is going to be the square root of all of that. All right, good. So let's see. 41 squared minus 40 squared gives us 81. And the square root of 81 is 9. Okay? So this is good. So we know that A is basically 9. Why are we choosing a positive 9? Because this is the positive x-axis. So that's very important. So can you see, this is us doing the clinical examination right now. From then on, we can do the assessments that, okay, now we've got 3 questions to answer. 82 cos theta plus sine of theta minus 180 degrees. Nice and easy. So what is the plan? 3-step approach. What do we see? Reduction formulae. So that's BODMAS right there. Okay, so we need to start dealing with that. So this is equal to 82 cos of theta plus, now how do we reduce this? Now remember, 180 on the Cartesian plane. Now these are things, guys, you need to notice by yourselves, because not all the time you will be taught these in class. Okay, I don't know why I'm writing y and x. Now when we put our angles here, we know this is 0 degrees and 360 degrees. So this is 90 degrees. This is going to be 180. And this is going to be minus 180 degrees. So this is where we are. But now, once we see this, this is as good as minus 180 degrees plus theta. And once we add, that's a positive angle. So it's anti-clockwise. So theta here is that angle. Nice and easy. So we can see clearly this is an angle in the third quadrant. So sine is negative. So can you see we used our BODMAS there, BO, brackets, parenthesis, which is in application here is reduction formulae or co-ratios. We continue, 82 into, essentially we can use our diagram now. Cos is defined as adjacent, this is the 9, over hypotenuse, which is 41, minus into, right, sine is going to be the opposite, which is minus 40, divided by hypotenuse, which is 41. Okay, good stuff. Now in this case, guys, we were supposed to do this without using a calculator. I forgot to read the entire statement with an aid of a sketch, and our answers must be in the simplest form. That means no sets and no improper fractions. Okay, so remember what this statement means. No sets or radicals, no square roots, and no improper fractions where we've got, for example, 5 over 2. We don't want that. It's a no-no. No improper fractions. So understand mathematical requirements or conditions. Otherwise you'll be in trouble. So we know 41 goes once, goes twice to 82. And we will have here 18 plus 40 over 41. Okay, this is a proper fraction, but it's not good. We need the common denominator, which is 41. Now 41 times 18 is what is it? What is it? What is it? What is it? Okay, what we can do here, we can just say 18 times 41. Sometimes just make it long because you don't want to run into problems. Then here we're going to have 1, so this is just 40. Because remember, we are forced not to use the calculator, so we need to show an indication that we did not. But sometimes when we do multiplication like this, you can get away with cheating. It's not a big deal. Now remember, this thing is suggesting that this is 18 times 41, all divided by 41, plus 40, all divided by 41, right? So 41 goes, so what is our answer? Is 18 and 40 over 41. So the answer must be a mixed fraction because it would have been an improper fraction. So at times, when the instruction is clear, guys, and it's even put in bold, it means not adhering to that instruction means a loss of marks. So don't lose marks because of just complacency. Anyway, where do we get the marks? Obviously, folks, we can assume that that is very important, right? Right. And essentially, this reduction, whenever we use our three-step approach, we get marks, okay? 2, this definition using our diagram, and that definition using our diagram is very important, and the answer in the required format. So this is 1, 2, 3, 4, 1, 2, 3, 4, 5. Of course, where's the 6th mark? We were told to do a sketch, so that should be the 6th mark. Of course, guys, I don't know where the marking guidelines of this question are. This was a side evaluation. Now, there's many ways of treating this. You can do this by understanding the Cartesian plane, which makes life a lot easier. But some people, when they have a situation like this, sine of theta minus 180 degrees, what they do, they factor out a negative and say sine of minus. Now, when we pull a negative, 180 becomes positive, the theta becomes negative. Okay? Now, we know that sine of a negative angle is minus sine of that particular angle. Remember, this could still be looked at as theta or alpha, even though it's a compound angle. It doesn't really matter. Now we do the reduction. This is minus into. Now sine of 180 minus. Now sine in the second quadrant is positive. So it's going to be sine theta. Therefore, we have minus sine theta. Okay, if you trust your algebra, please. Remember, in maths, you must trust in something. Either you trust your knowledge of functions, meaning you are comfortable with the Cartesian plane, or you trust your algebraic manipulations because they are the basis to maths anyway. Sometimes I would advise you to trust your algebra because not everything would work nicely using functions or the Cartesian plane. It's nice to know it and to know it well because it simplifies your life when that is possible. But algebra is always the key to any door. Yes, sometimes it takes you the long way around, but you just have to go. You just have to go the going. You just have to walk the walk. Okay, there's just no shortcuts sometimes. But when you can, do take them shortcuts. But remember, if there's any suggestion, for example, a student who just does the substitution here and runs for the answer, we know you did not follow the rules. We know, or at least we can assume you used a calculator and you lose those marks. So don't lose marks, guys. It's not fair. We cannot teach you to fail. You are wasting our time. Okay? Don't waste our time, please. We would rather sit at home and not do anything. If we're going to show you things and you don't see them still, but you don't tell us that you don't see them. Because if you don't follow, ask a question for clarity. If you think you follow, put it to the test by practicing. Because there's nothing that is more truthful than practicing, because you start to see where you lack. Some things you think you understand, but when you put it to practice, you realize, oh, I didn't quite get it. Okay? So there's a whole lot of revelations you get by going through the process. So you could see, guys, here that technically we just did our job nice and easy. Let me show you what we did. First of all, we drew our sketch because without the sketch, we didn't know where we were going. From the sketch, we understood this is a right-angled triangle and we're missing A. And we had to find that A. Even though we were not asked, we knew we do need to find A. Okay? So from there, guess what? We used a rule to solve for A. What rule was this? Pythagoras theorem. That's the third step right there. Then we substitute. From there, we have brackets, BODMAS. We solved all the way using BODMAS because when we see square numbers, we take, the opposite, doing opposite. What you call inverse operations. When we have perfect squares, we take the square roots. When we've got square roots, we square that thing. We always do the opposite mostly. You will see that. But at times, we just follow the order as it is stipulated. And from there on, we went into our expression. We recognized, again, a reduction formula, which is part of BODMAS. Then we reduced. After that, we substituted using our sketch. And again, BODMAS. Can you see 80% of our workings here have been just the first step? Although we did use our identities or laws in there. Nice and easy. So guys, this three-step approach can actually assist you to solving a complicated problem. Instead of getting lost, you can strategize using the three-step approach because it is directive, it's procedural. Because you just keep looking, can I still use BODMAS? If no, can I factorize? No. Then there must be a law. It's always going to be one of the three things that you can do every step until the answer. So this prevents an unnecessary parade where you just get lost in the woods and you don't know where you came from, you don't know where you're trying to go, you just cry. And guess what? The moment you cry, the animals, the predators are there waiting because you are letting them that you are vulnerable. Then they chow you. Then it's a sad story of one who tried but didn't make it. Please, guys, let's stop the narrative now. It's long overdue. We have to end the pain and the suffering and the lack of knowledge by aligning ourselves with what is right and stand for it to the end. But again, if we're going to be complacent in all of this, it will fail despite the efforts, okay? Just remember that. Anyway, 27 tan of theta, there's nothing we can do about this one for now. Minus, we see this is a reduction formula, right? Remember, guys, inspect the expression just like a doctor would. The part of the objective information, examination starts with an inspection before you palpate and percuss the patient, right? Okay, you don't start by palpating and percussing without having inspected, because you start palpating areas that are not relevant, and some of those areas are controversial if you find yourself in them. Don't be a bad doctor, please, or a useless engineer. You need to be very observant of what you need to correct. Don't go correcting things that don't need correction and miss one that needs correction, and you end up with a plane that kills people. Be a proper engineer. Okay, guys. Now this is a reduction formula, but now this is dragging a negative, so it's going to be negative sine of theta. Can you see? Now we are good to go. What can we do here? There are no like terms, so we need some sort of a definition now. This is 27 into tan of theta. It's opposite over adjacent. Opposite over adjacent. So this is going to be minus 40 divided by 9 for our angle theta. Minus into, we look at this, sine of theta is going to be minus 40 over 41. It's opposite over hypotenuse. We continue, guys. So we know 9 goes once, goes 3 times. Then 3 by 40 is minus 120 plus 40 over 41. Again, this is going to give us an improper fraction, so we leave it as minus 120 and 40 over 41, because that's what this is. Lord have mercy on students who do not adhere to instruction. Understand what simplest form means. Okay, it means no radicals, no improper fractions, no reducible roots. If you are stuck with the root, then it has to be the simplest set form. 2, no square roots in the denominator. It means that denominator must be rationalized. So these things we cannot overly emphasize, folks. You must have them in check. Anyway, this reduction is always good. Then the definitions, we defined sine above, but we didn't tan. So we can say that should be the mark. And essentially the answer in the required format. Here we can say the general substitutions to make up the 4 marks. Otherwise, nothing special in there. So let's see, 3.3, we've got cos of 2 times theta plus 1. Voila! What do you see? A double angle identity. Didn't we do this business? We did. But now we see there's a 1 here. So it's very nice because we know cos here can be looked at as 2 cos squared theta minus 1. Then plus that 1. So these are like terms and they cancel each other out. So we only have 2 cos squared theta. So this is 2 into cos of theta is adjacent over hypotenuse. So this is 9 over 41. Okay, this is squared. Now here we are stuck with the issue. So we know 9 squared is 81. 81 times 2 is what? Is 162. So this is 162 over 41 squared is what? Is 1681. Well, the one at the top is an even number, the one at the bottom is an odd number, so I doubt they will have anything in common. Let's check it out. 162 divided by 1681. It remains as it is, so there's no highest common factor. The good thing is it is a proper fraction, so we leave it as it is. So it means we have fully adhered to the rules given to us. Now remember guys, every time we use an identity, that's a mark. Okay, every time we make a definition based on the diagram, we get a mark. But I think we did get a mark for cos, but anyway, we have an answer there. It's not a big deal. We can say 3 marks is acceptable, but this should be 2 marks because we did define cos of theta above and got a mark for it. We shouldn't be getting a mark here. It's a sub question of question 3. So here the examiner is being generous, to be honest. This one should not be given. But maybe because it's squared now, okay, whatever. It's not exactly direct, but whatever guys, whatever guys. So can you see 13 marks, folks? Nice and easy. Of course, I took a bit of time to make sure that you understand exactly why you are being taught what you are being taught, so that you can assume independence. Now let's look at this question 4 quickly so that we have more practice on these issues. Now question 4, we are told that given that sine cos theta is equal to t. Okay, given that sine theta times cos theta is equal to t. And we are told 2 theta is an element of 0 and 90 degrees. So this is saying 2 times theta is an angle in the first quadrant. So this means theta is an acute angle, that when we double we still get an acute angle. Okay, determine in its simplest form. Can you see again, this is coming back I'm sorry that you may probably not see that because of this thing. I don't know why STEM Physics does this. It's ridiculous. But anyway, it's their website, so they can do whatever they want. But it's something I wouldn't want to call with your ears wide opened. I'd rather have them blocked first. Okay, the value of each of the following in terms of t. Can you see? Now we need to not solve for t, but everything must be in terms of t without using a calculator as well. So again, what do we do, guys? First of all, what the hell is this? Now, a student who's not suspecting is going to be killed because this is a higher grade question. It's not a standard grade question because now this is something that demands more from you. Now remember, I told you in maths we can do something that we want. We can either multiply by a number if we see something that we want to see, or we divide by, whatever we want to divide by, because remember, multiplication and division are reverse operations of each other or inverses of each other. So now what do we do here? What we see when we multiply sine to cos, what comes to mind is a compound, it's a double angle identity of sine. This is 2 sine theta cos theta. Now this forces you to think. So it would be like, okay, I can do whatever I want. If I have an equation, I can decide to divide if I want to divide. I can decide to multiply if I want to multiply. At the end of the day, I can get what I want. So this implies that, or perhaps let's just say we multiply by 2 here on both sides. So what do we get? 2 sine theta cos theta is equal to 2t. Remember, guys, in maths, whatever you do, because some student may ask, but why do I multiply by 2? Because I like to. Why? It's because I recognized I'm doing trigonometry. And in trigonometry, I can actually try to find my double angle identity, because if this is expanded like this, it doesn't make sense. And I cannot solve these things easily if I do that. So let's go on. So this also implies now, this we contract. If it is expanded, we contract. So this is the same as sine of 2 theta is equal to 2t. Can you see now? This is 2t over 1. Now we can take this onto the Cartesian plane. So that was what was tricky about this question. You wouldn't be able to go through it easily without sorting it out. Anyway, so this is the origin. So 2 theta, we were told, is an angle in the first quadrant. So there it is. Okay, so we anchor it onto the x-axis. Wow, not so straight. Okay. So this is what we have, guys. So obviously this is just, not a part of what we were given. So now sine is opposite, so it means we've got 2t over hypotenuse. So this means this is a unit circle, because what is the radius? 1 unit. So we need to solve for x, because look at what we are supposed to find, tan and sine. But sine is easy because we will then be able to proceed here, but we need to do it nicely, easily. So let's see, we know that x squared plus y squared is equal to r squared. Please, guys, don't shy away from doing this. It shows that you understand, because not doing it is an exercise that hurts a lot of students. And they wonder why. And it's just why. It's just why. All right, guys. So here I'm not interested in going through some difficulties. X is on the positive axis, so it's going to be the positive square root of 1 minus 4t squared, isn't it? Yes, that's what it is. So now that we have our x, we put it where it's supposed to be so that we don't forget. Nice and easy. So can you see, guys, again, we took information as given. We were then able to recognize something. You see, that's objective things. Now we're examining things. And then we work it out and say, okay, this is what it is. Then we have an assessment of something. That assessment will take us through the treatment plan. Okay, all right, okay. If you still didn't get the doctor's approach by now, then you will never get it. So 10 of 2 theta. Now, this is a very interesting question. Are you then allowed to do what I showed you guys? Well, okay, no, because remember this is just 10 theta as it is. So 10 2 theta is easy because we know it's going to be opposite, which is 2t, over adjacent, which is this business that we found. That's it. And there's nothing we can do here. Oh, by the way, the question said in its simplest form. Be very careful. We don't want radicals in the denominator. So what do? We then rationalize. Once it's a single square root or single radical, we just multiply by it, like so. Why am I doing what I am doing? You need to understand that in maths we can multiply by 1. 1 does not change the result. It remains as is. Hence it is called a multiplicative identity. Okay, so the key here was that we're just multiplying by 1. But this 1 is strategic because we're trying to rationalize. Okay, so this is going to be 2t, the square root of 1 minus 4t squared, all divided by, now this is just 1 minus 4t squared. Can you see this is a difference of 2 squares? So a difference of 2 squares is always a rational number. There's no need to do anything any further. So be very careful, guys. How the question is posed is how you should respond, but have a plan. Now we have 4 marks here on offer. So of course, solving for x, very important. Writing the definition, very important. The art of rationalization, very important, and presenting the answer in the required format. So there was a catch here. You would go wrong if you are very careless and lose marks. And I would happily lose you marks as your marker if you don't adhere to instructions, irrespective of your capabilities. Because guys, let's be honest, we cannot promote mediocrity because of, favoritism. It sounds good and looks good at the beginning. We don't want to punish students, they must just pass. But we are creating a liability, people who will be paid for failing. Because look at what our country is experiencing, guys. It's very clear that essentially we are rewarding people who are not supposed to be rewarded. Because performance is not constantly being evaluated. Even those evaluations are not properly conducted, in my opinion. Sorry guys, I'm just putting my phone on a charger. So those evaluations are just being done as a form of formalities. It's not really done by someone who is an objective assessor. It's just people who are just trying to get paid also who are doing the assessments. As a result, a lot of rotten potatoes keep rotting the system. And when now it's fully rotten, we claim it's the devil. If it's the devil, then we are the devil. Because we created that devil. Anyway, folks, however you take this, take it with a pinch of salt. Okay, so we want to deal with sine theta. Again, how will we solve for sine theta? Well, we can see that technically we need the cosine double angle identity here, or we need the sine double angle identity there, but that one is going to introduce cos theta, and we don't have cos theta here. You get it? So this is going to force us down a path of pain if we use the sine. But if we use the cosine dons, our lives are going to be super duper. Now, this question, you don't start here on what is given. This is why a careful assessment is important. This is a higher grade question, perhaps one that you can give an asterisk because it's not so clear. The tan to theta was direct, but it had its own issues. But this one is just like the very beginning. It's a hidden issue. So that's a higher grade question. Anyway, so we know that we can still say cos of 2 theta is essentially going to give us adjacent, this is the square root of 1 minus 4t squared divided by the hypotenuse, which is 1. Okay, easy. Now, what are we doing here? We know that, well, cos of 2 theta is nothing but 1 minus 2 sine squared theta. Can you see? Yes, it's like this. So this is as good as just this. 1 minus 4t squared. Now what do? We transpose that dude. We know that minus 2 sine squared theta is going to be equal to essentially this business over here, and then minus 1. Or we could easily say we take this and make it positive, we transpose it to that side and this one to that side. Essentially it makes this positive and this negative. So we can just say 1 minus that root there. It's too long. Anyway, so this is the story, guys. So what do we do now? We divide by 2. So we know that sine theta is going to be the square root. The square root of 1 minus this square root of 1 minus 4t squared, all divided by 2. Now, are we able to simplify this thing any further? Well, we don't want a radical here. So this is suggesting that sine theta, what am I writing? Sine theta is going to be equal to, now when I finally rationalize, folks, do you know what's going to happen? Do you know what's going to happen? Well, you don't know what's going to happen, but it's going to happen. Okay? It's going to happen. So, I'm thinking this is going to be the square root. Now, guys, I'm going to challenge you. I need you to find out how I got the answer, because I'm running out of space now. So this is going to be the square root still of, remember this is going to be root 2, right? We say root 2 over root 2. When you multiply that root 2 multiplies the whole thing. So this is going to be the square root of 2, right? Minus, now when you multiply by root 2 here again, we will get the square root of 2 minus this answer is crazy. I don't think I like it, but let me try to put it apart now, because I am not happy. I am not at all happy. Yeah, doch. Nicarele, sweswi. Nicarele, sweswi. Okay, let's do this nicely, guys, without rushing anything. So this is 1 minus the square root of 1 minus 4t squared, all over the square root of 2. So we need to rationalize. So this is why this question is no walk in the park. So what do we get? This multiplies here. So, well, root 2 is the same as essentially just multiplying the 2 inside the square root right here. So this is going to be the square root of, multiply by 2, there we get 2 minus, essentially this is going to be the square root. Again, root 2 multiply, okay, sorry, 2 multiplying here is just going to be like that. Yeah, I was almost making a meal here. So this is minus 4t squared. Yep, it's a complicated answer, guys, but what can I do? What can I do? All right, guys, so this one was poking you. It was poking you a bit, and it's a successful poking, isn't it? So this definition is key, right? Right. And whenever we use identities, yes, yes, yes. And essentially, this answer is a very complicated answer, but it's in the required format. So maybe we can say 2 marks for the answer, because, I mean, it's complicated. It's complicated. But we will score these 4 marks with a big smile for a total of a very painful 8 marks. Okay, guys. So because the video is gonna get too long, I don't want it to be so. So I will do this one alone. All right, because it has its own merits that we need to adhere to. As you can see, it's not quite an easy one. We also have this 3D structure. So I would rather we don't go too far, unless you guys are willing to walk with me. But I think these questions are fine. Let's stop here.